Okay, so I hope the screen is visible to all of you. So today I'm going to take the first week NPTEL tutorial of the course which is entitled as Principles of Organic Synthesis. Myself Sana Sheikh and I am a fourth year PhD student at IIT Bombay, and in this course live session we are going to discuss the different name reactions. So this is the week 1 course. So let's quickly start the session. So in this course we have 12-week syllabus. So in week 1 we are going to discuss the formation of aliphatic carbon-carbon bonds and base catalyzed reactions. So the formation of aliphatic carbon-carbon bonds and base catalyzed reaction is a part of the reaction part of the course, which included the two lectures, lecture 1 and lecture 2, which is already available on YouTube by Professor Punyamurthy from IIT Guwahati. So let's quickly start the session. So these are the book references I have given here. You can use these books, and then you can make a more practice for this type of questions. Now the first discussion, there are two types of aldol reaction. I hope everybody is aware of the aldol reaction. If not, we are going to discuss in detail. So aldol reaction and aldol condensation, there are two different reactions, but the aldol condensation product is observed by aldol reaction only. So the first we are going to talking about the aldol reaction. Here it is given. So what is the aldol reaction? So basically in aldol reaction, suppose we have here acetone, right? This is a acetone molecule. This molecule is called as a acetone one. Okay. So if we will subject this acetone in a basic condition, so base will abstract the proton, right? So which proton is more acidic? Here we have two CH3 group, right? So both the CH3 groups are have a proton which is acidic because of this carbonyl, alpha to the carbonyl group. That's why these protons are acidic, and because this is a symmetrical molecule, so both the protons have equal acidity, right? So the proton abstraction will take place, and we will observe that the intermediate which is in resonance to negative charge. Okay, here it is negative charge. It's not working. Actually today I don't have the writing pad, so sorry for the inconvenience, but next time onward I will bring that. Enolate ion it will be present in the enolate ion form, right? Enolate ion. Here double bond. Okay. So after the proton abstraction, what will happen next? This enolate will attack on the carbonyl center of the another acetone molecule. Okay. So from here to here. Okay, it will attack on carbonyl center. So the intermediate will form, which will look like this one. Okay, so it will take up the proton and give the intermediate or a product which is called as a beta hydroxyketone, this product. Okay, after taking the proton. So this is the aldol reaction product, the base catalyzed aldol reaction product. When we will again subject this substrate beta hydroxyketone in basic condition with sodium hydroxide, what we will observe? Condensation. What do you mean by condensation? Anybody knows about the condensation? Have you ever observed, if you are keeping out the bottle from the fridge, the small droplets are around the bottle, so we called it a condense हो गया है, right? That sense only, condense means water removal, we are calling it a condensation. So whenever the word is used condensation, that time remember that the water molecule will get removed. Okay, water molecule will get out. So here you can see that we have OH, right? And here we have 2H. Okay, so if this H will go, it will give a double bond here, right? Double bond. So then after the condensation, the product we will get is alpha beta unsaturated ketone, which is also called as a enone. Why enone? Because here ene, double bond is called also called as a ene, and here is ketone, right? Enone. That's why this is a product of enone, alpha beta unsaturated ketone. So I hope all of you got the difference between the aldol reaction and aldol condensation. So aldol reaction is a basically base catalyzed aldol reaction in which we will get the alcohol as a product. Beta hydroxyketone here we are getting, but secondary alcohol, uh, tertiary alcohol as a product or secondary alcohol, whatever depends on a substrate we are taking in a reaction. But in aldol condensation we are getting a enone as a product. So double bond will be there in the aldol condensation reaction. If you have any doubt regarding this, you can ask me. Otherwise, we will move to the next slide. Okay. So as I told you, today I'm going to discuss the lecture 1 and lecture 2 of Punemurthy sir from the YouTube. So this is the lecture 1, base catalyzed CC bond formation reaction. We are going to discuss this one. So have you ever heard about the kinetic control and thermodynamic control reactions and enolate formation? Okay, if yes, you can interact in this class. We are going to discuss, because this is an interactive session, so please feel free to give your answers and discuss here. Okay. Okay, so we have two types of enolates, kinetic and thermodynamic. If you want to know the difference between the kinetic product and thermodynamic product, then let me know. Then I will discuss in a future classes. Today we are going to discuss about the enolate, because in aldol reaction the enolate is very important. The reaction is proceed via enolate formation only. That's why. So when we are using a bulky base, this LDA is a bulkier base. What is the LDA? Lithium diisopropylamide. So because here the hindrance is too much and bulkiness is also there. So this is called, this LDA is also known as a strong bulky base. So when the strong base is there, the nucleophilicity is decreases, right? So this LDA, because of bulkiness, will abstract the proton from the less hindered side, right? Less hindered side. Suppose here we have unsymmetrical ketone, right? This one. This are here you can see that a tertiary carbon. Okay, here we have tertiary carbon, right? And here we have secondary carbon, this one. So because tertiary carbon is more substituted, it's a more hindered center, right? But the other side, which is less substitution is there and less hindrance, so bulky base will prefer that side. So always the bulkier base are preferring the less substituted double bond or a side, whatever you can say, less substituted side, it will abstract the proton. So after the abstraction of the proton, it will give this enolate, right? Kinetic control. So in remember that in enolate case, the less substituted double bond is formed, that time the reaction is going via kinetic enolate. And when the more substituted double bond is formed, that means the reaction is going through the thermodynamic enolate, and the reaction is thermodynamic control. So if you will use the smaller base and milder one, that time it will abstract the proton from the most hindered side, and it will give you a more substituted double bond, which is a thermodynamic enolate. Okay, so this is a basic difference. So always bulkier base will abstract the proton from the less hindered side. Okay, so because kinetic enolates are preferred because of the hindrance problem, that's why it's a faster reaction. The kinetic inlets always form faster due to the less steric hindrance and at a alpha carbon. But in a case of the thermodynamic control reaction, the reaction is slower due to the steric hindrance. Okay, and you can control this type of reaction by using a bulkier base at low temperature. But the when talking about the thermodynamic inlet, because in thermodynamic reaction the activation barrier is very high. To cross that barrier, you require a more energy. So maybe at high temperature you can get the desired thermodynamic control inlet formation. So kinetic is a in kinetic reactions, kinetic control product reactions, the energy barrier is always lower compared to the thermodynamic control reaction. So because the energy barrier is lower, the reaction is faster, right? And the because to cross that energy barrier, the energy required is not that much high compared to the thermodynamic control. That's why it also works at low temperature. So here is a difference between the thermodynamic control inlet and kinetic control inlet. Next, move to the next slide. Here we have an example of Knövenagel reaction. Okay. Have you ever heard about this type of reaction? Okay. This is a condensation reaction only. We'll discuss in detail. Here, suppose we have here two carbonyl compounds, right? One is acetone and the other one is ester, correct? So in acetone and ester, which proton is more acidic? Here we have 3 proton, alpha to the carbonyl center, right? Here. And here we have 2 proton, alpha to the carbonyl center. But in these two, which one is more reactive? Anyone? So here you can see that we have here 2 withdrawing group. Here oxygen is also there, right? Heteroatom. And here only carbonyl center. So this H are more acidic compared to the acetone one. And it will first undergo a proton abstraction reaction. So enolate formation, enolate will be stabilized here more compared to the acetone. So stability is also always matter for the enolate formation, remember that. So here it is more stabilized because it will in a resonance with this oxygen. Okay, so here enolate formation will takes place. You practice by yourself as well. So write in a notebook and check you are able to make a right product or not. Okay. So this is the enolate will get as an intermediate. Okay, leave it. So this is the enolate, and it because this is also stabilized by this lone pair of oxygen atom. Oxygen atom lone pair are there here to stabilize the enolate here. So that's why this enolate is more stable compared to the acetone one. Okay. So after the enolate formation, what will happen? It will attack on carbonyl center. Okay. So on this carbonyl center, it will attack and it will form a intermediate, or we can call the aldol product. Also we can call the aldol product, but not aldol. What is the difference between aldol and Knövenagel reaction? Aldol type we can say, but not aldol. So in aldol cases, we are doing a reaction on aldehyde and ketones, right? Aldehyde and ketones. And in Knövenagel, we are doing a reaction of ester with ketones. Ester with ketone. There are other different types of reaction also, which is also one reaction is there, which is known as a Claisen condensation. In Claisen condensation, both the enolate and the carbonyl compound is esters. Both the groups are esters. Okay, functional group according to the functional group they have divided the name reaction. So in Knövenagel reaction, one is a ester and other one is a ketone. In Claisen condensation, both are esters, and in aldol condensation, either aldehyde or ketone is involved in the reaction. Okay. So here it will attack on a carbonyl center and it will form a intermediate which will look like Wait a second. So what will form here? CH3 here O minus correct. Also got this one. After this one, condensation will take place. And we will get the product. This one. Okay. So here we are getting the product, right? So after that one, this one hydrolysis will take place. What is a hydrolysis? Ester hydrolysis will take place. So in ester hydrolysis, the name itself defines it. Hydrolysis means water addition, right? Hydrolysis. So water addition means this ester will hydrolyze to give the acid. It will attack here, and then it will knock out this one like this. Okay. So CH3 will remain as it is. CH3 double bond CH3, and here this will become hydrolyze. This will hydrolyze. Okay. Sorry for this product. Here CH3 will remain as it is. Okay. Okay. So this is a hydrolyzed product. Got it? I hope all of you got the mechanism here. So the first you have to make the inlet and then make a attack on another carbonyl center. So let's move to the next slide. Yeah. The Henry reaction. What is Henry reaction? So it is similar to the Claisen condensation or aldol condensation reaction, similar to the aldol reaction, but only the difference is that the functional group is a nitro. Okay, nitroaldol. It is also, we can also call it called as a nitroaldol. So in Knövenagel reaction, we came to know that one is a ester group and the another one is a ketone. So in Henry reaction, the one is a nitro group and the other one is a aldehyde. So if talking about the proton abstraction part, from where the proton abstraction will take place? Anyone? See, this proton is more acidic, right? Because it's a it's next to the nitro group, which is a more acidic. Nitro group is a very high electronegative group, so it will make this proton is more acidic and stabilize here enolate. Okay, the enolate will be stabilized here at this center. So that's why the proton abstraction will take place in presence of sodium hydroxide and it will form a enolate. Okay. Here we have two protons and these two protons are very acidic. So one proton abstraction will take place and this will give you this intermediate. Okay. Nitronate salt, and this nitronate salt will further undergo a aldol-type reaction with aldehyde or ketone to give the compound. So here it will attack on this carbonyl center. Got it? And we will get this as an intermediate. Now this will O negative will take up the proton by quenching the reaction and it will give you a hydroxynitro compound, or we can call it as a nitro alcohols. Okay, 1,2 nitro alcohols. So these type of reaction are slow and unfavorable equilibria. That's why these type of reactions are very rare, but the product is this one only. Okay. Next next reaction is Perkin reaction or Perkin condensation. So here we have in Perkin reaction we used the partner group anhydride. Okay. So in this case we are having a aldehyde or ketone and the other group is anhydride and the reaction is again undergo a base catalyzed condition only. So here what will happen? Can you tell me the acidic proton in this case? Anyone? Which one? Which proton is the acidic one? This one. Okay, and this one also. So there are because this is a symmetrical molecule, so both the protons have the proton abstraction will give the same product, right? So proton abstraction will takes place. It will form a enolate. Here you can see the mechanism. So base will abstract the proton here and it will form this enolate. Okay, after the formation of this enolate, it will attack on aldehyde carbonyl center and form the intermediate, this one. Then after getting this intermediate, it will undergo intramolecular reaction type. So this O minus will attack on a carbonyl center and it will open up. Then further this tetrahedral intermediate will further give the desired product by this negative charge will attack back here and this bond will break here and it will give the intermediate which will look like acetate transfer reaction. So you can compare here and here these two. Can you see here this O minus have a acetate group now. So acetate transfer reaction. This is a type of acetate transfer reaction, right? And you know how the mechanism is going. Now after getting this intermediate, this O negative will again attack on another molecule of acetic anhydride and it will give the intermediate which will look like this one, which is this one. Why, how is this possible? See here, this negative charge will attack on this carbon center and it will get open up, right? and then it will further attack back, and this group will leave out, knock out, right? So the O acetate group will knock out this. Okay. After that, getting this intermediate, the next thing is this acetate will again abstract the proton, which is acidic here, right? This proton is acidic, so it will abstract the proton, and enolate formation will take place, and this group will knock out. Okay, this proton negative charge will generate over here, and yeah, abstract the proton, and this group, this acetate group will knock out to give the double bond over here at this end. Okay, and after getting this carbonate intermediate, it will further subjected for the hydrolysis reaction, where this carbonate will get hydrolyzed to give the acid corresponding acid, which is a alpha beta unsaturated carboxylic acid. So this type of reaction is known as a Perkin reaction. This will, I know this will look like a very complicated mechanism, but if you will understand each and every step, then it will become very easy to you. Okay, please try to do yourself. If you have any doubt, any confusion in this reaction, you can ask me now. Okay, now quickly move to the next topic, next reaction, which is a Claisen condensation reaction, right? So I told you already, in Claisen condensation reaction, both the groups are esters, right? At the time of Knövenagel reaction, I was discussing about this one also. So here we have Claisen condensation reaction. Okay, in Claisen condensation reaction, both the groups are esters. So because these are the same esters, so any one of them will undergo a enolate formation. So proton abstraction will take place from any of the ester, and it will form a enolate. Here we have mechanism, right? This is a ester, and it will form a enolate. Okay, same, both are same. So it will attack on the carbonyl center of the another ester, and it will get open. Then O minus will push back to knock out this O ethyl group. Okay, ethoxy group will knock out to give the corresponding alpha beta keto ester. Alpha beta keto ester. So by Claisen condensation reaction, you can get the alpha beta keto ester. So here, what is the driving force? Suppose now after getting this product, you are thinking that this reaction, because base is already there in the reaction, so this reaction is further undergo a condensation reaction, right? So how is this possible? You are thinking it will, base will again abstract the proton from the acidic side, right? So here we have two protons, acidic proton. This is next to the carbonyl, and here also one proton is next to the carbon. But this proton is more acidic because of what? Because it's between the two carbonyl groups are stabilizing this proton, right? Where we have two carbonyl group. Here ester group is also stabilizing this proton. So this is a more acidic proton. So proton abstraction will always take place from this alpha position, and it will give us this type of intermediate. Then further what will happen? This negative, because this is stabilized enolate, it will again take up the proton and form the alpha beta keto ester, right? It will not attack on the another molecule because it is already stabilized. So the beta keto ester has a very acidic proton which is removed by the base, but when we will do the acidic workup, again it will take up the proton. Okay, so that's why this is the irreversible reaction. This is the irreversible reaction. Okay, now the next reaction is a Thorpe reaction. Thorpe reaction, it's a similar to the Claisen condensation reaction, but the only difference is that instead of the ester group we have a nitrile group. Okay, nitrile group. So in the, it can be a multi different type of starting material we can take in this type of reaction. So R is a general alkyl group. So similarly in case of Claisen condensation reaction also, both the ester can be a different also, or it can be a same. So cross Claisen condensation is a different ester used. So similarly here also in Thorpe reaction we can set that cross condensation product we will get if we will use the different nitriles, but here the example is given with same nitrile. Okay, here what will happen, we have two acidic center. Two acidic center, right? Because both are same, so we will consider only one here, and it will abstract the proton. Okay, here we have mechanism abstract the proton, and it will form here this type of intermediate. Okay, after getting this intermediate, what will be the next step? It will similarly, in case of the inolate, it was attacking on another carbonyl, right? So here we have different nitriles. So after the formation of the intermediate, it will attack on a nitrile group, right? Nitrile group. So always remember, this will attack on a here it is shown already. Okay, so it will attack on a nitrile carbon, and this double bond, triple bond will get, pi bond will get break. Okay, pi bond breaking will take place. It will form a intermediate which will look like this. After getting this intermediate, it will take up the proton, and again the proton abstraction will take place in presence of base. Here we have two protons. Proton abstraction will take place, and it will give you a condensed product. Double bond will come over here. So in wine product we will get here. In wine product. Okay, nitrile product. We can say nitrile product. Okay, so this is the mechanism of Thorpe reaction. Everybody is cleared with this mechanism? Any question, any doubt? Okay, let's move to the next one. The next session is, in today's class, is problem solving. Okay, discussion on problems. So here we have the first question where we have a predict the product of the following reaction. So here you can see we have two aldehydes, 2 mole of aldehydes. Okay, that means we have to do a reaction of aldehyde on another aldehyde. So we have already discussed different type of reactions. So I have clearly told you, when we are having a aldehyde or ketone, that time aldol condensation reaction is taking place, or aldol reaction. Okay, whatever. Condensation is the reaction where the water molecule is removing, and without that is called as a aldol reaction, right? Very first reaction we have discussed. So here we have aldehyde, So I will write here the mechanism. A proton abstraction will take place from here. Because in today's class we are talking about base catalyzed reaction, so I will give the mechanism of base catalyzed reaction here. It can undergo in acidic condition as well, but we are going to discuss the base catalyzed. Okay, so it will abstract the proton from here and CH2 minus. Okay, H, which is also similar to, sorry, which is in resonance. We can call this term with this. Got it? Now we have another molecule of aldehyde. Okay, so sorry, it will attack on this carbon to form an intermediate. Got this one? Everybody understood this one? This will take up the proton I have missed one carbon, sorry. Right? Correct? Which one is the product? We have here aldehyde, right? In these 4 example options, aldehyde is here, right? And one hydroxy group. So the hydroxy group is here. So the correct answer is option A. Got the mechanism, everybody? So this is the way you have to solve this type of questions and mechanism. Okay. Now next question. The major product formed in the reaction given below. So which type of reaction is this? Can you tell me the answer, anybody? Here we have the mechanism. Answer. How it will go? First of all, we have zinc over here, right? So this is a acidic condition reaction. So in acidic condition reaction, and zinc is also there. So zinc will always bind with the electronegative atom, which is here oxygen, correct? So it will bind with the oxygen, and halogen transfer will take place. So here you can see this intermediate. It will form this intermediate, and after the intermediate, now you can see this enol is formed, right? This is the enol, and this enol will further attack on the next another carbonyl center. Okay. And it will form the intermediate will look like this one. After that, getting this intermediate, okay, sorry for the confusion, because zinc can bind with the oxygen atom and make a stable intermediate. Always whenever you have zinc in the reaction, it will always bind to the carbonyl oxygen. Okay, carbonyl oxygen always. So because here we again have a ketone, and zinc can easily bind with the ketone oxygen also, so it will form the intermediate. It will look like this one. After getting this intermediate, now this CH2 will attack on, double bond will attack on a carbonyl center, and then the bond transfer will take place. So this is basically a chelate compound. Chelate, you can call this as a chelate. Okay. After this chelate intermediate, the bond transfer will take place, and the new bond formation will take place between the zinc and oxygen. Okay. After the chelation. So this is the mechanism of the reaction where the after the addition of water, it will give you a secondary alcohol along with the ester group. Okay, along with the ester one. So here we have R3 is our ethyl group, correct? Ethyl. And R1 and R2 are phenyl group. So this is the reaction mechanism for this type of reaction, and the correct option is option B. Okay. Now next question. Predict the product of the following reaction. Okay. So here again we have one ketone group and the another one is ester, right? So which type of reaction is this? We have discussed earlier, right? When we have ketone and ester, that reaction was a Knövenagel reaction, right? Remember? So the proton which is acidic is here, H. And this is the sodium ethoxide will abstract the proton, and it will form a okay. So it will attack on carbonyl center to form a COT, right? Till here all of you are clear. Now this oxygen, sorry, this is O minus. It have not taken a proton right now, so it will attack on this center, and chlorine is a good leaving group, so that's why it will knock out and the epoxide will form over here. This inolate, epoxide will form over here. Okay, got it? So the correct answer is option 4. Okay. Now next question. The major product formed in the reaction given below is. So here again you have to check the reaction condition. Here we have sodium ethoxide on arrow, right? And 2 esters group in a starting substrate. Okay, 2 ester group. So we have discussed today the Claisen condensation reaction, in which both the reacting species are esters, right? So that is the intermolecular reaction. Claisen condensation reaction is a intermolecular reaction, right? we have discussed, right? Plus suppose another. So this is the intermolecular reaction. But what if both the ester group are present in the same molecule? That time the reaction will go as an intramolecular reaction, and which is known as a Dieckmann condensation reaction. Dieckmann condensation. Okay. So we will solve the mechanism here. First, what will happen? The proton abstraction will takes place either from here or from here. Okay. So I am taking the proton abstraction here from this side. Okay. So you can take up the proton from any of the carbon and check the different type of product if possible in this case. Okay. So if proton abstraction will takes place, it will look like this one. Correct? Agree? Now it will attack over here and it will form. How many carbons are there in ring? 1, 2, 3, 4, 5. 5-member ring. Right? Got it? So at carbon 1, 2, 3, 4, 5. At carbon number 5, O negative will be there of carbonyl group, and the another one is O ethyl. Correct? And at carbon number 1 we have ester group. Correct? Now after this one, what will happen? This O minus will push back electron here and this OET group will knock out. Minus OET. It will give you a product which will look like this carbonyl group and here ester. Got it? Ketoester. So, ketoester is your product. So what is the correct option here? Anybody? Option number 2. Got this one? I hope all of you got the mechanism. If you are having any clear doubt or question regarding these questions or today's session, you can ask me right now also. Otherwise, I am going to upload this video on YouTube also. You can go and check the link which will be available soon. Now the question number 5 is predict the product of the following reaction. Now always whenever you are having a question, that time first of all you have to check the arrow condition. If it is H plus, that means it is a acidic reaction, and when it is a base on arrow, that time it's a basic reaction, right? Here we have H plus, means acid will get used. So here we will see the mechanism I have discussed here. So the proton abstraction, because today we didn't have discussed the acidic reaction, that's why I am giving here a full mechanism. So whenever we have an acidic condition, that time just protonate the carbonyl oxygen. Okay, just you have to protonate it. So we are going to protonate here carbonyl oxygen, right here. And oxonium ion will form over here. Correct? After getting this one, now this center is become more electrophilic, right? As, right? This center. Okay. Now the next is heteroatom, electron withdrawing atom, which will attack on this carbonyl center and form the intermediate Okay, got it? Till here all of you are clear? Now what next? The proton transfer will take place. So in proton transfer, you will see that this proton will go on the oxygen atom. So we will have here water and nitrogen is here, right? Got it? All of you got this one? Now this lone pair of nitrogen will push over here, and this water group is very labile, and a good living group, it will get knocked out, and we will get here the product, this one. Okay, now positive charge will come on nitrogen. Now after this one, this is the resonance structure, and the stabilized form is this one. It will form a stark enamine. This is a stark enamine reaction. Okay. So here you have to take care of one thing. I'll tell you. I forgot to mention here this methyl group. Okay, the methyl group we are having here. So always when the proton abstraction will uh, takes place, it will from the less substituted side. Why from the less substituted side? Because the bulky base or a hindrance factor. So the proton abstraction from the less substituted side is easier. So you have to take care of the base or what the thing are using in the reaction. So this is a stark enamine reaction. We have already discussed about the kinetic control and the thermodynamic control in the late formation, right? Same concept here. So this is the stark enamine reaction. Okay, and because the product is enamine. Okay, I hope all of you are clear with this mechanism. Now let's move to the next one. The major product of the following reaction is, here again we have two esters group. I have already discussed with you a Dieckmann condensation reaction. Similarly here again we have to do the same thing. What we have to because on arrow it is given a sodium ethoxide, which is a base at 80 degree. Okay, high temperature. So because the temperature is given high temperature, so which inlet will form here? Proton abstraction will take place, because here we don't have bulky base. I already told you, you have to check the base first. So because it is a weak base, not a bulky base and strong base, so it will abstract the proton from from the less hindered side. Okay, here. Okay, negative charge will generate over here, and it will attack on this carbonyl center, and it will get open, right? Then the negative charge of oxygen will push here, and the ring formation will take place. These two are both similar resonance structure. Okay, both are resonance structures. So it will form a 5-member ring, and then the ethoxy group is a good living group, so it will give you a cyclopentane as an intermediate. Okay, then after this one, again the proton abstraction will take place from the alpha position and from less hindered side, and it will form a inlet, stable inlet, which will again take up the proton to become a stable product. So this reaction is known as a Dieckmann condensation reaction. We have already discussed, but this is a major product. You can make a minor product as well. Okay, how you can make a minor product? Abstract the proton from here, it will attack on this one, and what will form? How the mechanism will go for the minor product? 1, 2, 3, 4, 5. Correct? 5. Okay. This is the minor product. So in Dieckmann condensation, there are possibility of other product as well. Okay. The mechanism is going via inlet formation. So I hope all of you are clear with this one. So the correct option is option number B. So here, because in question it is asked about the major product, so the correct answer is option B. Okay. Next one. The next question is given here. Again, you have to find out the major product of the following reaction. So we have already discussed about the nitrile reaction also, which is called as a Thorpe reaction. Thorpe reaction. Remember? So this is a type of Thorpe reaction where the proton abstraction again will take place. So from where it will take up the proton. Here I have given the mechanism. So because the nitrile group are more electronegative and this carbon is having a more acidic proton. So proton abstraction will take place from here and negative charge will generate over here, right? Then this will attack on a carbonyl center of the ester group and this will open up. Then further this oxygen lone pair will negative charge will push over here and methoxy will knock out as a leaving group to give the corresponding proton. If you are not understanding, I can write here step by step, but if you should practice yourself first. If you are not getting anything, you can ask me. Okay. So this is again the example of Dieckmann condensation reaction, but not exactly that one. It is a type of Dieckmann condensation reaction, or we can say the Thorpe reaction. Okay. Next, the major product of the following reaction. Listen one more thing. In this case, you have to find out the minor product as well. Here it is given the major product, but you have to find out the minor product. Do the mechanism by yourself, arrow pushing mechanism. If you have any question, any doubt, then you can ask me in a next session, next live session. Okay. Here we have the another question. The major product of the reaction is. Anybody? Just check the arrow. We have the sodium methoxide, which is a base. So when the base is given, always you have to abstract the proton, as you have to find out the acidic proton. Now talking about this one, these two substrate, here we have acidic proton, right? And here, which one is more acidic? Of course this one, because it is the in center of two ester group, so it is stabilized by both the esters. So this inlet will form more stable one. Okay, so proton abstraction will take place, so it will look like this one. Okay, so it will attack on, tell me, here the mechanism is given, how it will undergo. So because it is a conjugation system, conjugated system, correct? This is a conjugated system. Okay. So always 1,4 reaction will go here. I will write somewhere else. Okay. 1,4 reaction will takes place to give the intermediate. Got this one? Then it will take up the proton and becomes a product like this one. Okay. Then again we have base in the reaction, so it will abstract the proton, correct? So base will abstract which proton now? This is the proton and here also is the proton. So this proton is less hindered, right? So it will take up this proton. Okay. Abstraction of this proton and enolate formation will take place, and then this negative charge will attack on the carbonyl center of ester group, and OMe will knock out to give the corresponding cyclohexyl ketone, diketone. Okay. After getting this diketone, the hydrolysis will take place in presence of water and sodium hydroxide, which will hydrolyze the product to give the corresponding diketone cyclohexane intermediate. Okay. All of you got this one? So whenever you have a conjugated system, always do a 1,4 reaction, 1,4 addition reaction. Okay. Now let's move to the next question. The major product of the reaction is, here again we have a sodium hydroxide. On arrow you have to check first of all. Basic condition, correct? Basic condition means the reaction will go via base catalyzed mechanism. So here base is there, that means it will abstract the proton. So which proton is more acidic? Now here this is a quaternary center, so we don't have any proton here, right? So we have here or here, correct? We have here or here. So which proton is acidic? Because here we have hindrance, so it will abstract the proton from the less hindered side. Which is also similar to got it? Okay. Now we have another carbonyl center in the molecule. So it is an intramolecular type of reaction, right? Intramolecular condensation reaction. So this will attack on this carbonyl center, and it will form how many carbon rings will be there? 1, 2, 1, 2, 3, 4, 5, 6. Okay. 6 carbon. So we have here ring as it is, then this ring, and from here correct, all of you are getting this one. Here we have CH3 group, and here we have carbonyl group, because attack is taking place from this carbon number 1. So I will give the numbering, then it will be more easy for you. Carbon 1, 2, 3, 4, 5, 6. Got it? OH. Okay. Now here also we have H. So it will undergo a condensation reaction and it will give you a product which will look like this. Alpha beta unsaturated in product. Okay. So all of you got the mechanism. The correct option is option number 4. I hope all of you understood this one. Next one. The major product of the reaction is. Now the another substrate is given on the arrow. Can you see this? Nitrile ester, right? So here we have aldehyde here, and here ester and nitrile. So which proton will be more acidic? I will write the mechanism for you. So here negative charge will come here because this proton is more acidic. It is stabilized by both ester and nitrile group. So it will this inhalate will attack on a carbonyl carbon of aldehyde, right? So if we will write aldehyde by opening it, okay. Minus CO empty. All of you got this one, and it will take up the proton to form a OH. This is this one. After getting this intermediate, what will happen next? Condensation. Condensation is a removal of water molecule. All of you got this one? It will give a this as a product. So this is the example of Knövenagel reaction. We have discussed in first reaction only. After aldol condensation, we have discussed the Knövenagel reaction. Now next question is, here we have a cyclopentanone. Pentanone reaction with lithium hydroxide. So again the base is given on the arrow. Got it? So here we get to mark the product, option 3. Okay. Now here find out the major product of the reaction. Again we have base and the another group is isopropylaldehyde. Isopropylaldehyde, which is this. All of you got this one? And we have here lithium hydroxide as a base. Okay. So as you can see here, this is a very hindered site. And talking about the cyclopentanone, it can, this site is more available to abstract the proton compared to the isopropyl alcohol. So it will abstract the proton from cyclopentanone and negative charge will come over here, and it will attack on a carbonyl center of isopropane node. Now what will be the intermediate product? Got this one. Now condensation will take place or not, because on arrow there is not given a condensation reaction condition, so we will not do. But if the condensation will takes place, that time it will form this as a product. Got it? Yeah, option A is condensed product, condensed. And option number 2 is a aldol reaction product. Yeah, talking about the stereochemistry, you have to imagine the molecule in 3D. So if this negative charge will attack on the this carbonyl center, the OH will get the go on the other side, right? Back side. And suppose it's attacking from the back side, right? So it will give you a stereochemistry is not correct. The molecule will attack. If it will attack from the back side, then hydroxy group will come on the front side. If it will attack from the front side, that time hydroxy group will go on the back side. Correct? All of you know this thing? I hope all of you know this thing. So if it will attack from the back side, that time hydroxy group will come on front side. This way. Okay? So this is the correct answer. Not this one. Okay? Next. Sorry for the confusion. Here we have the transition state as well as So according to the transition state, here we can see that we have isopropyl group on axial position, correct? We are keeping this in this way, so the enolate will attack on the group and this isopropyl group is downside by keeping the hydroxy group on equatorial position. But here both the things are possible. You can make the intermediate this way as well. Okay, so both the options will correct. It's a slight tricky question. But here you can see that on this position the hindrance will be there with the lone pair of oxygen, but here it is not there, right? Lone pair of oxygen will be there, so that's why this is the more stable one, more stable transition state. The reaction will proceed via this transition state only, and you will get this as a product. If you will imagine the product in 3D, that time we will get to know that this bond and hydroxy is on front side and this bond is back side, axial equatorial things. If you know the cyclohexane chemistry, you can easily get the answer. Okay, so isopropyl group is on back side. So just imagine the molecule in 3D. If you are not understanding, let me know. We'll discuss these type of molecules in detail in next class. Okay, next question. The major product of the reaction is here. Here again we have the base catalyzed reaction, because on arrow we can see the base is there. Right, base is there. So base will extend the proton. Which proton? Which one is the more acidic proton? All of you know that this one. Correct? Am I right? Right? So here the proton abstraction will take place from here, from this carbon, and negative charge will generate. Then what is the next step? It will attack on this carbon and the bromine will knock out. So what will be the intermediate? This one. All of you got this one. Now another we have another base molecule, sodium methoxide molecule, will abstract the proton and then negative charge will generate over here, and then this negative charge will again attack on this carbon. Okay, like this way you can see in this case. Okay, which will form a O-alkyl ester. Why then this negative charge is not attacking only oxygen, is attacking on this carbon? Anybody? Because the stable ring formation will take place. Ring size is always influencing the reaction, favored reaction. So here you can see that the 6 member cyclic ring is forming, which is stable compared to the 1, 2, 3, 4, 5, 6. Okay, and the double bond is stabilized by oxygen lone pair. It is a resonance in oxygen lone pair. So the correct answer is option number 3. Okay. Next question. The major product of the reaction is. We have discussed about the Henry reaction. Remember, in Henry reaction we were saying that the nitro group is there instead of the aldehyde and ketone, right? So here we have nitro group. This is a type of Henry reaction, and on arrow we have a base, right? And the thing is aldehyde, acetaldehyde. Got it? We have acetaldehyde. So what will happen? The proton abstraction will take place from this carbon, and negative charge will come over here. It will attack on acetaldehyde. Correct? What will form then? Correct? Okay, it will take up the proton and form this product. And the second condition is H2SO4 and water. So it is a which condition? This is the acidic condition. So in acidic condition, hydrolysis will take place, and the last step is a this acidic condition reaction name is NEF reaction. So anybody know about the mechanism of NEF reaction? Anyone? What is NEF reaction? So basically the NEF reactions are the organic reaction that converts a primary or a secondary nitroalkane into a carbonyl compound. So carbonyl compounds, so we will see the mechanism over here. So because it's an acidic condition reaction, it will protonate first, right? So protonation I will write here. Okay. This is same as the product we have here. Okay. Now here we have acidic condition. So here after getting this product, base will abstract the proton from here again, and it will form this as an intermediate. After getting this one, protonation will take place. Okay. Then the protonation, after the protonation, will get the plus charge here. CH3 and nitrogen OH. Okay. Again the protonation will take place and it will give the nitrogen OH, sorry, like this intermediate. Got it? Now next thing is water. Water will attack on this carbon and it will give you a intermediate which will look like this one. Got it? Then proton removal will take place to give the now the next step is very simple. Water removal will take place. How? This will push over here electron and two water molecule will get eliminated to give the byproduct as a this one is as a byproduct and the product will be carbonyl OH. All of you got this one? The correct answer is this one, option number 3. I hope all of you understood this one. I will upload the slides also on the drive. You can go and check there also. Okay, next question. Now the next question we have methyl vinyl ketone on arrow we have and basic condition sodium acetate. Okay, so here we will discuss the mechanism. First of all, you have basic condition is given, so proton abstraction. From where you will do the proton abstraction? Okay, so because here we have first condition methyl vinyl ketone. So methyl vinyl ketone is given and sodium acetate. So this lone pair of electron will attack on the carbonyl center. Okay, and it will get open. Okay, then to knock out to give the product. This one. This one. Then after getting this intermediate, these two are the resonance structure of each other. Okay, so these are resonance structure of each other, so both are stabilized. Then sodium acetate is there and this is a methyl vinyl ketone given here. So this is a Michael reaction condition. So it will undergo a Michael reaction condition. How it will go? This 1,4 attack on this carbon will take place. Okay, so the intermediate form right here Okay. This type of intermediate it will form. Then after the hydrolysis, we have already discussed about the hydrolysis mechanism. This group will get hydrolyzed to give the corresponding ketone. And further in this case, Robinson annulation type of reaction will take place to give the corresponding product. So how it will take place here? From this carbon, the acidic proton abstraction will take place. Negative charge will come over here and it will attack on this carbon. Okay, so if we're talking about the ring size, one, two, three, 4, 5, 6 member ring formation will take place. So it will form a ring which will look like this one. So I'll give the numbering to the carbon to make it easy. So this carbon, carbonyl carbon, is number 6, correct? 6, 5, 4, 3, 2, 1. So on carbon number 1 we have this group. Sorry. So at carbon number 2 we have carbonyl center. Correct? Now it will undergo a condensation reaction to give the product here. The correct option from this one is, this reaction is option number 1. This last step is called as a Robinson annulation. Robinson annulation reaction. Okay. Now move to the next step. Next is the major product of the reaction is, so that LDA is given, which is a bulky base. All of you know that, right? At lower temperature also this reaction is going. So the mechanism will have given here. We have already discussed in Thorpe type of reaction. We have nitrile group instead of carbonyl center. Okay. So here we have 2 acidic protons. So proton abstraction will take place from here because LDA is added. It's a strong base, so proton will get abstracted. Okay, from here. Now it will attack on carbonyl center. I will write here by opening the reaction. Okay, this way. Okay, so how many carbon ring size will form? 1, 2, 3, 4. 4 members. 1, 2, 3, 4. 4. Okay, so here we have double bond and on carbon number 1 CN. For this one, after this one we have the hydrolysis. We have discussed already in Thorpe reaction case. CN will remain as it is. Protonation will take place and it will look like this one. Then further it will get isomerized to give the primary amine. Okay, this is the product we will get here. So the option number 2 is the correct option. Got it? I hope everybody understood all the mechanism. If you have any question, any doubt regarding this session, you can ask me on during the class in next session, or you can write in a comment section of the YouTube channel. I am going to upload this on a YouTube channel, and the log sheet will be get updated soon. Okay. So in next class we are going to discuss the other name reaction. Till that, just practice these type of questions and make sure you are doing a correct arrow pushing mechanism. Thank you so much for your kind attention. Okay.